Okay, you're muted. Can you hear me?
I should now be unmuted.
I cannot hear you. I figured this was going to happen. I switched my speakers. Give me 1 second.
Hello? Sorry, folks. Technology sometimes happens. This is clearly one of
Okay,
those
now can you hear
moments
me?
of tech. I could hear you before.
Now can I hear you? No.
Oh, headphones. You want
Okay, now can I
headphones.
hear you?
Hello, hello. Hi, everyone. Mersey dotes and
I'm going
dozy
to
dotes.
reload this. Okay, hold on. Sorry, everybody.
Oh, wow. Sorry. Nothing quite like blankly trying to figure out what to say. Okay, so of random things to say until Fraser can hear me. Minute
Now
physics didn't. Can you hear me?
I can hear you. But I
Okay.
don't. It's coming out of my speakers, which is bad because that could cause echo.
Yeah. Why aren't you wearing earphones?
I was trying, and it decided that it didn't want to do that.
Were they
So
USB earphones or Bluetooth earphones?
no, they're standard jack, but the speakers are USB, and so it's not from one jack to another, right? It's trying to be very clever. So
Yeah.
anyway, you know what? I will mute and I will risk it. Some browser tab somewhere. So I want to warn people in advance. Some browser tab somewhere is gonna play advertising after 10 minutes because that's how people roll these days. Hey Pamela,
Hi.
how's it going?
It's going well. You saved the audience from hearing me read the minute physics version of Twinkle Twinkle Little Star that is scientifically accurate, and they should all go just look
Go
at the
on.
video. You
No,
haven't
no,
heard?
let's proceed with this.
Oh, this is awesome. So this was written by Henry Reich and Zach Wienerstein. I don't know, Wienersmith rather. I don't know how he actually says his name. He does Saturday Morning Breakfast.
Yeah.
So it's Twinkle Twinkle Little Star, you look small 'cause you are far. Light years out from here to there, your light's distorted by the air. So you, Twinkle Twinkle Little Star, adaptive optics show you as you are. Twinkle Twinkle Little Star, you must be a small pulsar. Out away from Earth you drift, this is known from your redshift. Twinkle Twinkle Spinning Star, degenerate neutrons are what you are. Twinkle Twinkle Little Star, supernova, au revoir. I can't speak French.
Au revoir.
Yes. You got so big, too big perhaps, electron capture, core collapse. Twinkle Twinkle former star, a black hole's all that you now are. Twinkle Twinkle Little Star. Wait, actually no, you're a meteor, breaking up in the atmosphere. I wish I'd known you'd end up here. Twinkle Twinkle Shooting Star became a meteorite that hit my car.
That's awesome.
There is this amazingly adorable video on YouTube that Zach animated, and it is simply fabulous, and everyone should go watch it right away.
Well, everyone should always be watching Minute Physics anyway because
Yeah.
those videos are just so great. And Henry is just, he's a master at communicating the stuff. And then to have Zach Wienersmith, I'm going to guess, to animate it this is just like a total, it's a total nerd.
It's a giggle fest is what it is.
It was like when the They Might Be Giants did
Big Bang Theory
of the sun. Well, they did Big Bang.
Oh,
No, they did the sun, right? They
Right.
did their song about the sun and sort of got the sun is a massive incandescent gas, and they sort of did a great job of talking about the sun. Cool. So, and that wraps up holiday. That wraps up. What is it? The retelling of nursery rhymes with proper science with Dr. Pamela Gay. So next week we'll be tackling Three Little Pigs.
Oh,
no,
man.
you have stumbled into an episode of Astronomy Cast, and I'm Fraser Kane. That's Dr. Pamela Gay, and we're going to be doing a live episode of of our show. That takes us about 25 to 28 minutes, depending on how much Pam has to say on the subject. So we'll take that time, and then we'll stick around after, and we'll answer your questions about space and astronomy, or start translating, finding other cool things we've seen on YouTube and talk about them instead.
And for those of you out listening live, because it won't still be true for those who watch this on the recording, if you need a United States tax write-off, it is not too late to donate to Astronomy Cast, CosmoQuest, and it's a tax deduction. And
you have 2 days.
You have 2 days. Promote science. Astronomycast.com. Click the link that says contribute to the show, help the show, and then there's a button that you click to donate. CosmoQuest.org/donate is all you have to do. Tax write-off, do science all at once. It's awesome.
Perfect. And so one other, I guess, piece of housekeeping is that I'm going to be helping out Dr. Brian Koberlein tomorrow. They're doing a mini hangout-a-thon. I think they're doing about a 3-hour hangout-a-thon to help promote the work they're doing. And that's tomorrow. I think I'm going to be on at 11:30 Pacific Standard Time. But if you go to briankoberlein.com, you should be able to find out more information about the hangout-a-thon, the mini hangout-a-thon that they're doing to promote their show. I forget the name of the show, but it's just like the kids.
We love you, Brian. We're sorry.
Yeah, but anyway, I'll be jumping in there and talking about Universe Today. So if you want to hear more information about how I promote science in Universe Today and what I think about space journalism and things like that, that'll be tomorrow.
Cool.
11:30 Pacific time. So I guess we should get on with this thing we call a show. We can't delay this any longer. We have to actually do it.
Yes.
So let's get cracking. So are you ready to record?
I think I have everything open, and yes.
Okay. Oh no. I have to go to headphones.
Why?
Well, because your audio is going to come through my microphone.
Yeah. Okay.
So I'm gonna
sorry,
try
audience.
this again, and hopefully it's gonna work. Man, I take these USB microphones. So let me see if I can switch it over without unplugging.
Can you hear me now?
I can still hear you. Hold on.
Can you hear me through your headphones?
Not yet. Not yet. This has got to be just so much fun.
We're sorry, audience.
Keep talking.
Maresy dotes and dozy dotes.
Perfect.
Okay.
We're good.
Little lambs eat ivy.
No.
A mare will eat ivy too, wouldn't you?
You can just keep going if you want.
That's all there is to it.
Okay, all right. Okay, cool. Well, I think then at this point I'm ready to press record.
Okay.
Okay?
Yep.
Say when.
I have pressed record. It is recording in stereo.
Oh,
I
denied.
suck.
But you should be able to just save it and it'll always record in mono. I remember with GarageBand that you always had to switch it back over.
I'd been editing something yesterday.
Mm.
So, yeah. Yeah, we're going to have new videos to promote CosmoQuest, and they have stereo audio. Okay, I'm pressing record. I'm in mono. It's working. It's going. Hi.
Awesome. Okay,
Hi,
great.
Preston.
And so am I. All right, here we go. Astronomy Cast, episode 362, Carolyn Porco. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos. We'll help you understand not only what we know, but how we know what we know. My name is Fraser Kane. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Doing great. And so do we have anything that we want to promote or let people know about this time around?
It's the International Year of Light, and I'm far too enthusiastic and overcaffeinated.
Oh,
So starting
okay.
January 1, 2015, there is a global celebration of the International Year of Light. There is an astronomy cornerstone called Cosmic Awareness, and we're working to get everyone to understand that light pollution bad, light from stars good. Let's celebrate light from stars, reflected light from stars off of planets, and all of the information that we get back in the form of radio light from spacecraft, and say down with light pollution.
Down with light pollution. And then the other thing is, if by the time you receive this, Comet Lovejoy maybe is going to be a comet that you can see with the unaided eye in dark skies. I think it's going to get to magnitude 4.
It's trying.
Yeah, so this is it. This is the comet that the universe has owes us, and I'm a little underwhelmed. I want another
Hyakutake.
I want a Hyakutake. I want the Ison that we were promised. So this is a good start. Okay, so let's get rolling. So it's hard to think of a more influential modern planetary scientist than Carolyn Porco, the leader of the imaging team for NASA's Cassini mission exploring Saturn. But before Cassini, Porco was involved in the Voyager missions, and she'll be leading up the imaging team for New Horizons. And before we get going on the show, I just want to apologize in advance to Carolyn Porco for the mistakes that we're going to make, because we've done our research, we've done the best we can, but I'm sure we're going to make a few errors, and this whole thing just comes from such a sort of deep level of respect and admiration for the work that Dr. Porco does. Literally, the work on Voyager, the work on Cassini, the work we're going to be seeing on New Horizons, so I apologize in advance, Dr. Porco, because she will tell us.
She will. And this is the one scientist in this series that I've never heard speak. I'm not quite sure how this has happened. She's a frequent public speaker, but it's just managed that I'm either just never at the right conferences or something.
Yeah.
So I don't personally know her other than occasionally sharing tweets and being on the same lists, and that doesn't mean I know her. It just means our names have been listed in proximity on the internet.
Yeah, and I shared an anecdote sort of at the end of the last show in the questions and answer period, which, by the way, at the end of every episode when we do our live show, we handle all the Q&A at the end of the show. And so if you want to get your questions answered, just come and watch the live show that we do. You can get information on that from our page on Google+. And anyway, and then we answered sort of questions, and I was talking about Carolyn Porco, and sort of my first interaction was with Dr. Porco, which she literally taught me how to properly attribute images that come from various space agencies. So whenever I would post an image of Cassini's images of Saturn, I would go, image credit NASA JPL, and then Dr. Porco reached out to me and said, you got to include Space Science Institute, because we're the people who are actually taking the pictures and processing them and doing a lot of the work. And so at that point, I understood the chain of all of the, that there's NASA, and then there's the JPL that works for NASA, and then there's Space Science Institute, and there's the Cassini imaging team, and each of these people have a hand in bringing you this final image that we get a chance to see. And so since then, I've gotten way better. So that was that's my interactions with Carolyn Porco. So who is she?
She is a scientist. No, but seriously, to give a better background, she is an imaging scientist who's been working on studying objects in the outer solar system literally since I was playing with Barbie dolls. It's one of those times where every once in a while you get told, I've been doing this since you were, and there's always like playing with tricycles, playing with blocks, playing with Barbie dolls. And she finished her bachelor's degree in science in 1974 when I was still in diapers. She finished her PhD in 1983 working on the Voyager spacecraft at California Institute of Technology, where she was working on the rings of Saturn when I was a child with Barbie dolls. And she has continued throughout the entirety of my lifetime to contribute to a lot of the different spacecraft that have inspired me throughout my life. when I was a kid, as I've talked about in the show before, it was the Voyager mission's data that really inspired me, that my parents more than once let me stay up late to watch the data coming back. And she was one of the scientists that helped understand the rings of Neptune, the rings of Uranus, how they're shepherded by moons. She worked on the Saturn data for her dissertation. And all of this early amazing work, all of this done in the years right after finishing her PhD, put her in a position that when the Cassini mission began its planning stages heading up towards launch, she was selected in 1990 to head the imaging team for the Cassini-Huygens. This meant that she'd be the person in charge of the group of humans dealing with the pretty images that everyone sees in the news. There's lots of different instruments on Cassini that do lots and lots of different science, but it's those images that everyone uses as their background on their computer, as the beautiful color images on the covers of magazines. She's the person that makes those happen.
And I don't think people really realize how these missions work, and how that that you have a mission like Cassini, and it's really just a platform for a whole bunch of science experiments. And each science experiment on that mission is run by a different team, sometimes at different universities. And so there's people who work at NASA, JPL, who are actually helping to make sure the whole spacecraft is operating, that it's receiving its data, the communications to and from, the telemetry of the spacecraft. But the individual instruments themselves are run by different people, and they often will have their own Twitter accounts and their own Facebook pages, and they'll handle their own press releases. And so, as you say, the main camera imagery on Cassini is just another instrument that's used for various scientific studies.
And I think this gets summed up really nicely in terms of just how complicated the politics in this mission are on saturn.jpl.nasa.gov, which is one of the cooler NASA URLs. It says the Cassini partnership represents an undertaking whose scope and cost would likely not have been borne by a single nation, but is made possible through shared investment and participation. Through the mission, about 260 scientists from 17 countries will gain a better understanding of Saturn, its stunning rings, its magnetosphere, Titan, and other icy moons. And so you have European leads, you have American leads, you have contractors, you have instrument scientists, you have participating scientists, and all of this is led under project scientist Linda Spelker right now, with deputy project scientist Scott Eddington and project science system engineer Nora Alongi. And what I love about this mission is right now, 2 of the 3 top people in the mission are women, and you see strong female participation throughout the mission. And as you look through all the different instruments, there's a plasma spectrometer, that's a whole bunch of lines, no one ever wants to see those. There's a cosmic dust analyzer. This allows us to understand the compositions of the bits of debris that can be captured from the rings and as they pass near the atmosphere. This is amazing science, but again, the scientists doing this aren't producing pretty pictures that appear in the news. There's an infrared spectrometer. Again, amazing science. This is what allows us to start seeing the molecular chemistry of the mission. Again, data no one ever wants to look at the pictures in the public.
Yeah.
There's an ion neutral mass, and I could keep going. But then when you hit the imaging science subsystem, this is one of the smaller teams. The magnetometer team is even smaller, but the imaging science subsystem is one of the smallest teams, and it's the team that everyone sees everything they're doing.
Yeah, and think about some of this. Like, do you remember when the day the Earth smiled? Do you remember that thing that happened was it about like a couple of years ago? And they were going to recreate that pale blue dot image that Carl Sagan helped organize with the Voyager spacecraft, and where everybody smiled in the general direction of Saturn, and then they posted an image of the sort of the new picture that was taken by Cassini of Earth from orbiting Saturn. And these are the kinds of things that she has helped organize to sort of help get that word out and really help feed that enthusiasm for space.
So that was back on July 19th, 2013.
Yeah.
And what was amazing about that is for her, it was a chance to redo something that she was part of before, because she was part of the team that planned the Voyager imaging that didn't just do Carl Sagan's pale blue dot, but actually did a portrait of our entire solar system as Voyager looked back on the solar system.
So let's go back into her career and sort of start with, I guess, her work on Voyager and sort of what she was involved there.
So with her dissertation work at Caltech, she was focused on looking at the rings of Saturn. It was with Voyager that for the first time we had sufficient detailed imaging to start to see that there were moons inside the rings, the spokes in the rings, and all the other structures that appeared. She was working with dynamicist Peter Goldreich, and it was during this work that she started to try and put forward models looking at what are the causes for these spokes. From there, she went on to be part of the Voyager imaging team, working at the University of Arizona following her successful completion of her dissertation. She was a tenure-track professor, getting tenure in 1991. And through her work with the Voyager team, she kept looking at rings. She was the lead of the rings working group for Voyager, and the rings on the outer two most planets, Uranus and Neptune, are just weird.
Mm-hmm.
And she was one of the ones that really worked to try and understand why they were weird and the role that moonlets and small moons have in shepherding the, in some cases, incomplete rings and in creating the divisions that we see in these rings. And so that is an amazing combination of using computers when computers were just starting to be able to do complex modeling to understand complex dynamics of what she was seeing in the imaging data.
And so a lot of the stuff that she helped discover at Saturn and I guess some of the outer planets, but really at Saturn, what was amazing was then she got selected as the leader of the imaging team on Cassini-Huygens, and was then be able to verify with much better instruments a lot of the stuff that was very tantalizing, but they weren't able to really see very close up.
And one of the coolest things that they've been able to follow up on is she'd predicted that oscillations inside of Saturn, acoustic oscillations, this is where sound waves traveling through Saturn actually affect its dynamics.
Yeah.
That these acoustic waves moving through Saturn actually have an effect on the rings around Saturn. And that's a really precise thing to think about and realize, where we know that stars oscillate, we suspected that planets could oscillate, but to carry that through and say, okay, a sound wave actually creates a density distribution change inside of the star. That should affect gravity. I wonder if we can see this in the rings. There's certain ideas that people come up with that make perfect sense once you articulate them, but where in your brain do you find that creative spark to come up with that idea is not something everyone has the ability to do, and this is one of those predictions that really shows that creative spark that is so much a part of being an excellent scientist.
It must have been so frustrating to come on to Cassini, to know the capabilities of the spacecraft, and then when Cassini got its mission plan, I guess, changed to take a longer route to reach Saturn using various gravitational assists. I mean, I'm trying to remember when it launched, but it probably didn't get to. When did it get to Saturn? In sort of 2004?
launched in 1997.
Yeah.
And it did a Jupiter flyby in 2000, arrived in 2004 at Saturn.
Yeah.
And so here she is, 14 years after being selected to lead the imaging team.
Yeah.
And she's finally at Saturn.
Finally at Saturn.
And the thing is, though, this is the mission that has just kept going and kept producing awesome results all across all of the different missions. During the most recent senior review, the team that did the senior review said that Saturn is one of the most well-managed spacecraft going. And so where they were originally planned for 4 years, they've now done 10. They're looking at a further extension. And we did an entire episode on this that you can go back and listen to, but of the 514 gigabytes that they've taken, and that's not a lot of data. When you look at missions like Solar Dynamic Orbiter, they do that every single day. With their 514 gigabytes of data, they have published well over 3,000 papers. And they've discovered 7 moons.
Yeah, let's talk about some of those discoveries, right? 7 moons. New rings.
New rings. They've confirmed the spokes in the rings. They've started to make sense of them. They've looked at the storm patterns. They've discovered, and this was part of the imaging team that Dr. Porco is part of, they discovered that there are vast hydrocarbon seas on Titan. They've found snow is perhaps not quite the right word for frozen methane and ethane, but they've found frozen formerly liquid stuff falling out of the sky onto the surface of Titan, and then in some cases melting or sublimating. Weather on other worlds, that's just a great thing to be able to start to study, start to see in detail.
They were the first people who saw the cryovolcanism on Enceladus.
Yes, and I'm kind of like, so many different things happen that it's hard to know what to hit on highlighting, because this is a mission that has spent 10 years doing amazing science. And part of the reason that we know about so many different things that it makes me tongue-tied and speechless is because through her work, Carolyn Porco hasn't just been a solid scientist, she's also been out there as a speaker. A lot of people have the mistaken notion that she's the principal investigator for the entire Cassini mission, because she is one of the most public people on the mission, rather than just being in charge of the most visible part of the mission. She dedicates a lot of time to going out and communicating what she does, being a consultant on CNN, doing profiles for a variety of different science shows. She's appeared on things like Stargazing Live and the BBC. And through all of this communication, she's helping to continue the legacy of Carl Sagan, who was actually one of her mentors, someone that she worked with early in her career. And in fact, she was a consultant on Contact, which, of course, Carl Sagan wrote the book that it's based on. And it's said that Carl Sagan told Jodie Foster that in trying to figure out how to portray this character, a character modeled after Jill Tarter, who's very much alive, he said, look at how Carolyn Porco conducts herself and use her as a model for how to act. And that's just kind of odd and awesome.
That's pretty interesting. I didn't know that he'd offered up that as the model for the movie. That's really cool. So, I mean, in addition, of course, and then I guess the latest thing, in addition to the work on Cassini-Huygens, is now it's time to spin up for an entirely new a new mission, a whole new project, which is New Horizons, which, of course, we've been reporting on New Horizons for 10 years. I actually had a chance, if you look back on my feed on YouTube, about 3 weeks ago or so, I hosted a hangout with Alan Stern and the Postdocs. I guess that's their new band, and all the people who are going to be, some of the science team that are working on the New Horizons mission. Of course, they're going to be providing these first close-up pictures of Pluto next year. And by about May or so, the images from New Horizons are going to be better than the images from Hubble. And this is the point where we then stop having to use those same old boring images of Pluto and the artist
Hubble
illustrations.
images.
Yeah, the boring Hubble images of Pluto and the artist illustrations that we've been using for decades, you know, since I've been, you know, like literally for 15 years since I've been doing reporting on this stuff. I've been using the same 5 images of Pluto for every single story that we do. So we're finally going to get new images of Pluto, and Dr. Porco is going to be the one who's going to be helping usher these into our eyeballs.
And it is a large team, and she is part of that team, and it's going to be amazing to see how all of the different science comes out of this, because she's an expert on rings and moons and how all of these different bodies interact. And as we've studied Pluto more and more with the Hubble Space Telescope, we've realized this is a really odd object. It's one of the larger of the Kuiper Belt objects. It has a moon that orbits such that it's more of a binary system, where the center of mass of Charon or Chiron, depending on how you pronounce it, and Pluto is outside of both bodies. There are a variety of additional moons, and it's thought that there could be an icy ring. And talk about having the right person to do the job. This is someone who's worked systematically on how moons affect the dynamics of systems, on the containment of rings, ringlets at Uranus and Neptune, and now she has one more object to sort out crazy, awesome, icy dynamics.
Right. It's going to be it'll be sort of a different kind of mission, though, because the thing with Cassini is that it's been orbiting Saturn for, as we said, 10 years now, and it's got years still to go, we hope. But with New Horizons, it's going to be this flyby. So all of this work is going to be in this tiny little crunch, and the kinds of operations, spacecraft operations, they're going to have to do is going to be this really tight coordination. I mean, part of the thing is that as they get closer, they're going to be getting better and better resolution images of the environment, and they're going to know if there are other objects they're going to try and make observations of. And then they've got this like 13-hour delay, or whatever it is, 4-hour delay? Anyway, multiple hour delay, I'm thinking it's 13 hours, to reach New Horizons and give it, you know, new directions on where to face the camera and what features to point at, and if it has to make any kind of trajectory changes if there's debris or moons or stuff that they weren't expecting as they get there. So it's a completely different kind of challenge, right? Like, you know, just imagine that they're going to be, when it's starting to happen and that flyby is happening and New Horizons is going so fast, they're going to have to be making these snap decisions to get as much science as they can as it quickly zips past Pluto. So it's a totally different game. I mean, it's going to be
Voyager all over again. If you think back to the beginnings of her career, it was all about the flybys. And now we have a flyby with much higher tech, or at least as high as it goes with NASA given when it was built. And so you have this new spacecraft that is new technology, but the same sort of data run that she saw with her dissertation work at Saturn and her follow-up work at Uranus and Neptune. So sometimes you return back to your origins. But this time we have her on Twitter. And one of the things that I know from my personal experience is everyone assumes that I'm significantly younger than I am because I dye my hair and use social media. And I love the implication that social media instantly knocks 10 to 15 years off my age. And it apparently does the same thing to Carolyn Porco, because I made a lot of assumptions about her age based on her appearance and her use of social media and was utterly wrong, as I learned in preparing for this show. So here you have someone that is awesome at social media, did not grow up with a cell phone in her hands, but has figured out how to communicate the excitement of day-to-day discovery, the pain of the politics that comes with Well, sometimes you're more politician than scientist when you lead a collaboration. And she's going to be bringing us all of these new discoveries, one paper and one tweet at a time.
So I'm gonna read a quote here, which was an award that she and actually Babak Tafreshi won back in 2009, the Leonard Nielsen Award, and the citation reads: Carolyn Porco combines the finest techniques of planetary exploration and scientific research with aesthetic finesse and educational talent, while her images, which depict the heavenly bodies of the Saturn system with unique precision, serve as tools for the world's leading experts. They also reveal the beauty of the universe in a manner that is an inspiration to one and all. And I think that's great. What's funny is she had, like, literally just a couple of days ago, she wrote a new post on the Cyclops. This is the Cassini imaging team's website, about this aspect of the rings, which she found quite fascinating. There are these cliffs on the edge of the B ring, which are like 2.5 kilometers high. So normally the whole ring is flat, at some point 10 meters thick. But there's a point on the B ring where there are these strange cliffs caused by some of the moons, I think, where they're like 2.5 kilometers high of this like jumbled cloud, and they actually cast these shadows on the rings. And so she had sort of mentioned how fascinating this was, and someone sent in some art to show what it might look like if it was a spacecraft gliding across the top of the ring. So you can just see this kind of imagination is captivated by the kinds of things that she's looking at, and she's able to express this fascination at the same time doing the science and going, this stuff is beautiful and this stuff is important scientifically. And that is, you couldn't ask for anything more in a scientist, to have those two things. It's what Carl Sagan had. I think it's what you have. And I think folks like Phil Plait and a lot of the scientists who are doing the research but also really helping express that enthusiasm, and it's infectious. And so kudos to Dr. Carolyn Porco.
And if you want to see her in action, she's done a pair of TED Talks, and I see from folks on Twitter, David McKee's pointing out that she was on the June 29th episode of Star Talk Radio. And so you can catch her doing her thing, communicating science in a way that will get you to fall in love with the understanding that she brings us about the universe.
Yes, go to the Cyclops website and sign up for her email newsletter, which is where you'll get like missives from her once every month or so, and then you can follow her on Twitter, right? Carolyn Porco, I think, on Twitter. But you search it up, you can find it, and talk to her directly, or at least listen from her.
Sounds great.
Awesome. Well, thank you very much, Pamela, and we'll talk to you next week. I think we've wrapped up this series on modern women in astronomy. So I think we're going to go back to Fraser's crazy ideas about space and astronomy from here on out.
Yeah, so we have no clue what our next big idea is going to be. So feel free to pipe up and make suggestions, and I have Fraser's awesomely long list of things to choose from.
Wonderful. All right. Thank you very much, Pamela, and we'll talk to you next week.
Sounds good, Fraser. Talk to you later.
Boom. Save.
Yep. I managed to magically adjust the gain on my microphone so that it picks me up and does not pick up the space heater.
You got mad skills.
It's cold. My office was really cold.
Yeah. It's really cold here too. The Christmas present that the children are battling over is the electric blanket. So my daughter got an electric blanket and my son did not. And he got something else. Yeah, and so he's just like, he loves it. Really wants to use it all the time. It's hilarious. So they do kinds of deals. If Logan will watch a movie that Chloe has been really wanting him to watch, then he can use the electric blanket for the night. So it's a way to because Chloe's been nagging him to watch various movies and stuff with her. Watch this video, on YouTube. So it's pretty funny.
That's kind of awesome and hilarious.
Yeah, but he got a bunch of money for Christmas, so he's gonna buy himself one. but they're pretty great. Okay, cool. Well, this was fun. Let's dig into some questions. I hope they're there.
Cool.
I didn't even look.
On Twitter, there is a great discussion about drunk birds going on.
As it relates to this show?
No, it's just going on.
Okay. Okay, so Jim Meeker says, is the Brian Coberline Hangout for Prove Your World? Yes, Prove Your World/donate, I think, is the thing that we will be working on. So go to proveyourworld/donate, but also just go to briancoberline.com. You should just go to follow Brian Coberline on Twitter anyway, and support his Patreon. By the way, anyone who wants to make a Patreon campaign, a space-related Patreon campaign, let me know. I will nag people to support your Patreon. So
we're about to launch a Patreon to fund Learning Space.
Awesome.
We have everything set up. We're just waiting for the final university approval, which we hope to get when the university opens back up next week.
And, of course, I've got a Patreon page, so patreon.com/universetoday. We're up to $1,700 a month. So,
damn.
Yeah, almost-ish. $16.80, I think. So,
cool.
And that gives you no ads on Universe Today. It gives you advance access to all of our videos. You get to see all the blooper reels that we do, and we get to see sort of all of the rough animations and stuff that we're working on. So, we've got about 35 1-penny sponsorships you can still do. So if you want to support us on Patreon, you pay 1 penny, essentially never pay any money, and you get Universe Today ad free and get to sort of join in our shenanigans. So check that out. And I will give that kind of a pitch for anybody who, all of the space peeps who start their own Patreon campaigns. I'm looking at you, Morgan Renberg. Okay. We've been nagging Morgan to do a Patreon campaign. Okay, or Phil Plate. Anyway, he's, I guess maybe Slate's keeping him busy.
Yeah.
So, Tom Nathy asks, are Saturn's ring spokes an artifact of the acoustic waves coming off of the planet?
No, they're more complicated than that, and I don't remember the details.
Okay.
I'm sorry, that was a lame answer.
Okay, Ilad Avron says, hey everyone, Pamela, just so you know, your name came up a couple of times in the ESG forums as a person we would like to see replace Rebecca Watson now that she's quitting the show. Of course, we've told them you have your own show, but it's a compliment. So
that is a huge compliment, and
yeah.
I am not sure I would say no to that.
Do you hear that, Steve? Pamela wouldn't necessarily say no, but I think we could probably. It'd be kind of weird, I guess, but we could line up. It was great having a woman on the show who was a skeptic, and so Rebecca really brought, in addition to her personality, which is very kind of outspoken.
I don't have her personality.
Yeah, no, I know. She will. I think you're a little more gentle than Rebecca would be for the kinds of things.
Nicole Gallucci, I have brass ovaries, but I'm more polite about it.
Yeah. So anyway, those are hard shoes to fill. I honestly can't think of a person who would be able to bring what Rebecca brought to the show. Huge entertainment. So I really like Rebecca. We hung out at Sci-Fu and a couple of years ago. It was really a lot of fun, a lot of shenanigans. It was great.
I have a lot of respect for the fight that she's been fighting for years.
Yeah, absolutely. So anyway, so Nicole would be fun. And that's the thing. Like, we could obviously suggest a rotating cast of people who could sort of jump in and get in there. But man, Pamela would be great. So, there you go. Let's move on. I'll talk to Steve. I'll pass your name along. Let's see.
As we scroll through all the things.
I don't see a lot of questions. Yeah. Tom Nathy also suggests, how about an episode about hydrogen deuterium ratios between comets and asteroids and water here on Earth? That's interesting.
That's actually kind of cool.
Yeah, I think we did an episode about water everywhere, and I think we've talked about comets, but there's a lot of... we haven't
talked about how isotopic ratios vary as you change your distance from the sun in the formation cloud.
Right, but this is one of those things, right? That the research from Rosetta, one of its big findings was that it really looks like the Earth's water didn't come from comets, and that it might have formed in situ. And this is like one of those moments where people would ask us, "What's changed?" And this feels like we're on the way towards one of those things that might have changed.
One data point does not a theory completely change. So it's...
Yes. But they landed on a freaking comet.
They landed on a duck-shaped freaking comet.
Yeah.
But at the same time, the water had to come from somewhere. Mm-hmm. So it's a complicated situation.
67p, that's all I'm saying.
Yes, it did not. Well, of course it didn't. 67p is still out there.
Right. So, or comets like 67p. That's all. That's all. Yeah. I think that would be, we could do an episode about where the Earth's water came from, and I think that would be fun.
Yeah, that is true.
I'll dig and see if we've actually done that show, because we've done a lot of shows, 362 now. Those are all the questions that I saw there. I'm going to say hi to Nancy Graziano and Brian Coberline and Phoenix Torres and Helga Bjorkog and Guido Beaver.
Oh, cool. Phoenix is on.
And cool. Yeah. And
there's people that don't get to come on normally because they're at work, and it's awesome to get to do this over the holidays.
Yeah. And Jim Meeker and Aze Micah, and yeah, that's awesome. Okay, now's your chance, folks. Come on, questions. Hit us. Get us. There's less viewers live because we've moved to the own separate YouTube channel, which I know is a little tougher.
Yeah, but we shared it everywhere, so that shouldn't matter.
Yeah. So I will remind you one more time. Here we go. For the International Year of Light, this comes from Phoenix, are there any initiatives to have specific LED technologies? Are there any initiatives to have specific LED technologies useful for astronomers?
So I'm not sure where that question is going. So LEDs in general are kind of the bane of our existence for the very simple reason that LEDs that get used for optical lighting tend to be strong in the blue, which first of all causes a lot of sleep problems. Second of all, scatters much more effectively off of pavement. So using a low power LED, you still end up with more light pollution because it scatters more effectively. So astronomy and LEDs, not one another's friend. We're strong advocates for, red LEDs are fine. Red LEDs are kind of awesome for the eyeball. But when we're doing science, you need different lighting that doesn't scatter quite so readily for street lights, and you need, for protecting your own vision, reds, and then you need, for doing your flat fielding, things that more resemble the solar spectrum and give you a complete spectrum of light rather than individual lines, which is what you get out of LEDs.
So what's like the perfect light if you want to protect astronomers? Apart from no light.
A shielded, compact, compressed sodium, rather. A very well shielded, pointing downwards, preferably not onto a highly reflective surface, but we don't generally worry about that as much. But that combination of using something that's more in the reds and then shielding it so the light isn't going upwards. And the stupidest thing you can do is have illuminated buildings where you have that light out in the lawn pointing upwards, where so much of the light goes straight up into the sky.
Right. So, if like all red streetlights would be best. That would be great. Wouldn't that be cool?
It would be thoroughly creepy.
Yeah, it would be super creepy. But if all just lights at night were red, and so you're just walking around and it's just red everywhere.
I'm pretty good with the compressed sodium. It's a good orangey hue. Tends to not quite be as horror movie red light district. Don't combine those two ideas. I've been watching way too much Criminal Minds.
Okay. Josh Andrews says, have you considered doing a show on space programs outside of the U.S., Russia, ESA? We've
I think
done
we
a bit,
have.
but we should totally. there's such a great program. Well, there's China. We've done it. I think we've done an episode on the Chinese.
Yeah.
Then there's the Indians and the Japanese. I don't think we've done an episode on the Japanese space program.
No, I don't think we have.
Yeah.
JAXA.
Yeah, so that would be good. So maybe we could do one on the Indians and the Japanese. That would be cool.
A roundup of the Google Lunar X Prize teams that are still in the play for the extended prize.
Right. Cool. Well, some great suggestions, people. Thank you very much. Okay, cool. Well, let's wrap this up. So, any last? How can people find out more about Dr. Pamela Gay? Where can they follow you?
They can go to cosmoquest.org and contribute to science by helping map out the moon, Vesta. If everyone listening right now went and marked craters and features on 10 images, it would make my day. And then I blog personally as Starstrider, and that's where you'll find me, either as Pamela L. Gay or Starstrider across all of social media.
Awesome. And of course, I'm F. Kane on the Twitters, and Fraser Kane on Google Plus, and Universe Today is my website, and definitely check out my YouTube channel. So, well, thanks again, Pamela, and I won't see you until next year.
Nope.
So
have a great New Year's, and enjoy the awesomeness that is a zip line that your kids have and an electric blanket they wore over.
Exactly. Yeah, we built a zip line in the backyard for the kids for Christmas. So, yeah. Okay. Thanks, everyone, and we'll see you all next week.